You have built a web application. It works. Customers are happy. Then one day, the business tells you they want to switch the database, or add a new user interface, or swap the payment provider. And suddenly, you realize your business logic is tangled up with your database code, your framework, and your user interface. Changing one thing breaks everything else. This is the problem hexagonal architecture was designed to solve, and once you understand it, you will never structure a project the same way again. Hexagonal architecture, also called the ports and adapters pattern, was created by Alistair Cockburn. He first wrote about it in 1994 and formally published it in 2005. In April 2024, he published a full book on the subject. That means this is not an old idea that has been forgotten. It is an idea that has been growing in relevance for 2 decades, and today it is the recommended architectural approach for applications built on Amazon Web Services, Lambda functions, Spring Boot microservices, and many other modern systems. In this video, you will understand what hexagonal architecture is, how its key parts work, how it compares to what you already know, and crucially when you should and should not use it. To understand hexagonal architecture, you first need to understand the problem it is solving. Most developers start with what is called a layered architecture. You have a presentation layer at the top, a business logic layer in the middle, and a data access layer at the bottom. Each layer depends on the layer below it. This sounds clean, but there is a hidden problem. Dependencies flow in one direction downwards. Your business logic depends on the data access layer. Your data access layer depends on a specific database technology. Now imagine you want to switch from one database to another. You have to touch the data access layer, and very likely the business logic layer too, because the two have quietly become entangled over time. The same problem appears when you want to test your business logic. To run a single unit test, you need a real database connection. No database, no test? That is not a good situation. Alistair Cockburn looked at this and asked a very simple question. What if both the user interface and the database were treated the same way? What if both were considered external things that just plug into your application, rather than layers that your application is built on top of? That question is the seed of hexagonal architecture. The core idea is this: your business logic, your domain sits at the center. It does not depend on anything. It does not know what database you are using. It does not know whether requests come from a web browser, a command line tool, or an automated test. Everything external connects to it through well-defined interfaces. Those interfaces are called ports, and the concrete implementations of those interfaces are called adapters. Let us look at the 3 key parts in detail. First, the hexagon. This is your application core. It contains your business rules and your use cases. Nothing in the hexagon knows about databases, user interfaces, or external services. If you are building a banking application, the hexagon knows how to transfer money, validate an account, and calculate interest. It does not know whether that request came from a mobile app or a scheduled batch job. It does not know whether the data is stored in PostgreSQL or in memory. The hexagon is pure. Now, a quick note about the shape itself. Alistair Cockburn chose the hexagon not because there are exactly 6 parts to the concept. He chose it because every other architecture diagram used squares, and he wanted a shape that was symmetrical and had enough edges to represent multiple ports and adapters around the outside. The 6 sides are simply a design convention, not a rule. Second, ports. A port is an interface. It is a contract that says this is how you talk to the hexagon, or this is how the hexagon will talk to the outside world. There are 2 types. Driving ports or inbound ports are used by the outside world to trigger actions inside the application. A request to place an order goes through a driving port. Driven ports or outbound ports are used by the application to communicate outward. When the application needs to save data, it calls a driven port. Third, adapters. An adapter is the concrete implementation that sits outside the hexagon. A representational state transfer controller is a driving adapter. A database repository is a driven adapter. An email sender is a driven adapter. An automated test can even act as a driving adapter. Adapters translate between the external world and the port interfaces. The hexagon never talks to adapters directly. It only talks to ports. One of the most confusing parts of hexagonal architecture is the distinction between the left side and the right side of the diagram. Let us clear this up for good. The left side is called the driving side. These are the actors that initiate something. A user clicking a button in a web browser is a driving actor. A scheduled job that runs at midnight is a driving actor. An automated test script is a driving actor. All of them communicate with the hexagon through driving adapters, which implement or call driving ports. The driving adapter translates the incoming request, whether it is an HTTP request, a command line argument, or a test call, into something the hexagon understands. The right side is called the driven side. These are the systems that the hexagon needs in order to do its work. A database is a driven actor. An external payment gateway is a driven actor. A message broker that publishes events is a driven actor. The hexagon defines a driven port and interface, and the driven adapter implements it. The hexagon asks for data by calling the port. The adapter decides whether to fetch it from a database, from a cache, or from a third-party service. The hexagon does not care. Here is why this matters in practice. Because the driven side is hidden behind an interface, you can write a test that replaces the real database adapter with a fake, in-memory adapter. Your business logic runs exactly as it would in production, but without needing any real infrastructure. Testing becomes fast, reliable, and isolated. This is one of the biggest practical benefits of hexagonal architecture. You may have heard of clean architecture, proposed by Robert C. Martin in 2012. Clean architecture combines the ideas of hexagonal architecture and the onion architecture into a diagram of concentric rings. The innermost ring is entities, then use cases, then interface adapters, then frameworks and drivers on the outside. The principle is the same: dependencies always point inward. Business logic at the center depends on nothing. Infrastructure at the outside depends on the business logic, not the other way around. Hexagonal architecture and clean architecture are not competitors. They are cousins. If you understand one, you understand most of the other. The key difference is that hexagonal architecture is more focused on the left and right symmetry, the idea that all external actors, whether they are drivers or databases, are treated equally as things that plug in and out. Clean architecture adds more layers of detail inside the hexagon. Compared to traditional layered architecture, the difference is more fundamental. In a layered architecture, the database is at the bottom and business logic builds on top of it. The database is not optional. In hexagonal architecture, the database is just another adapter on the outside. It is completely replaceable. If your team is already comfortable with layered architecture, and your application is simple, mostly straightforward create, read, update, and delete operations, then layered architecture is perfectly fine. Hexagonal architecture earns its cost when your application has multiple input sources, multiple output destinations, or a long expected lifespan where technologies will change. Hexagonal architecture is powerful, but it is not always the right choice. Use it when your application has complex business rules that need to be tested in isolation. Use it when you need to support multiple user interfaces, for example, both a web application and a command line tool using the same core. Use it when you expect the technology around your application to change a database migration, a new messaging system, or a new integration partner. Use it when you are building a microservice that will live for years and be maintained by multiple teams. Do not use it when you are building a small, simple application with straightforward database operations and no expectation of major change. Do not use it when your team is unfamiliar with the pattern and you are under tight time pressure. Hexagonal architecture introduces additional interfaces and adapters, which means more code upfront. On a small project, that is overhead without benefit. Most experienced teams start with a layered architecture and migrate toward hexagonal as complexity justifies it. That is not a failure. That is good engineering judgment. Hexagonal architecture is one of those ideas that sounds complicated but is built on a very simple principle. Protect your business logic from everything that can change. Databases change. User interfaces change. Third-party services change. Frameworks go out of date. But the rules of your business, if you design them well, should stay stable for years. Ports and adapters give you the walls to make that possible. If there is one thing to take away from this video, it is this: dependency direction is everything. Always make your infrastructure depend on your domain. Never let your domain depend on your infrastructure. That single rule is the heart of hexagonal architecture. Now, have you tried hexagonal architecture in a real project? What was the hardest part to get right? Drop it in the comments. Every answer teaches the whole community something.